I would like to thank you all for coming to my session. It's really a pleasure for me to come to the first Foxtrot Days and present from resilient to anti-fragile, a chaos engineering primer. My name is Sergiu Bodiu. You can follow me on Twitter. I'm a solution architect. I also co-organize the Singapore Spring User Group and the DevOps Days conference. My background is mainly in software engineering, and I don't call myself an architect. It's more like a combination of all of the above. And I'll try to explain, what I understand as an architect. It's more like the definition of PATQA, which gives a nice block, well-rounded architect. So you're an experienced developer, you're system-focused, you need to be entrepreneurial, and you need to think in technology in terms of a strategic direction, which means you need to communicate the future version of it pretty well. And of course, you need to lead some of the changes in your organization. So I think that's, in my definition, a good. It doesn't mean that I'm all of the above, still growing. So one of the topics which I'm very interested is risk management. And I think I've seen many organizations where they go through multiple levels and they try to build resilient organizations. And they are asking themselves, like, what's next? So once we build the resilient level, what would be the next level? Or how can we perfect our risk management framework, our compliance or security or anything like in this area? So I think if you imagine a very stable IT system that doesn't need any operator, and suddenly it crashes, after 20 years of operating. Think of it like COBOL mainframe. Nobody even knew we have a COBOL mainframe until it crashes. So what do? You actually have to call a consultant who has been in the beaches of Panama for the last 20 years, and you have to fly in with a private jet or with one of the rockets from Elon Musk. So actually, breaking things is very similar like the firefighter drills or the military drills that we are doing. So there's no wars, but you still have the NS service for 2 years in Singapore, and they ship you to some of the hot areas, so at least you understand, what's the real world. And there's a very interesting part. Anti-fragile is actually not an English word. It was added into the dictionary by Nassim Taleb, but more about it in the next slide. So I'd like to take you through this scale of risk management, or like a scale of organization. So there's a lot of fragile organization. That could be, your mom and dad's shop, like very small businesses. They're very fragile. They go with the wave, and after the product, think of it like the Chinese porcelain. So it's very fragile. The same is like our snowflake service configuration. Resilient, it's more something like from nature, from flora. So it's the bushes, the trees. You chop the trees, and they will outgrow from the trunk. Robust is something that would be, for example, the diamond, who is the defining material on the MOF scale of strong material. Whereas anti-fragile is something that it's more like its response to change. Think of it as Virgin Group. Virgin Group is not an airline. It's all of the above. It's food, it's logistics, it's financial industry. It diversified that so much that you cannot actually put an identity to it. So when organization, think of it like IBM. IBM, I think, transformed 3 times over the course of the past century, from intelligent business machine, mainframe, and now it's no longer, it's actually, I think it was beginning of this year, when it's not longer maintaining the mainframes. It's sold that business, and it's focusing on its Watson business and professional services. As I said, anti-fragile is not actually an English word. It was invented by this author, Nassim Nicholas Taleb, who actually wrote very interesting books about psychology, about nanny states, about politics, economics. He himself was a hedge fund trader on the Wall Street, so he was looking very much at the risk between organizations and what will happen in the event of crashes in the markets, political uprisings, and other. It's very difficult books, but I do advise you, once you are interested in the organizational aspect of information technology, or systems thinking, do have a read of these books, Black Swan and Anti-Fragile. It's very important because it builds on the fallacies of distributed computing. So I think every junior programmer starts with, I'll just build an app and we'll roll it to production. Or currently, as it is the case, ship my Docker container to production, or ship my laptop into the rack. I think there is a maturity level where, we understand that the network is not reliable. Latency between distributed systems, as we go on this microservices architecture, we add hops. The bandwidth, it's not infinite. It's actually, you have all this noisy neighbors. The network is not secure. If not, actually you need to be paranoid who is sitting not next to your rack, but whose building is next to you. If you know the case, I've listened recently to an FBI podcast, and they actually said we are that paranoid that for our super secrets, we still write them on a piece of paper, we maintain them in a safe, in a vault, behind a lock, behind the security zone building, and we never digitize it. Administrate, transport cost is zero, the network is homogeneous. I'll probably also add that our users read the documentations. As we go with, you probably heard about software is eating the world. It's true, software is eating the world, but it's creating a bigger problem. Actually, software is now the single point of failure. If you are looking at the recent news, what's happening in the industry or around the world, as we become more software-driven, airplanes, airlines remain halted, banks cannot transact, retail stores don't accept your credit card. And, for example, a lot of us probably do shopping online, and there's delivery and credit card, but you still want to have a grocery shop next to you, so in case if something happens, you can buy at least the basics. So there was this paper about the evolution of software architecture, and in this study you can probably see in the lower left corner, the unknown. It's about 92% of all the years. So this is a single point of failure. One example would be the recent AWS, where they maintain their status page of S3 on an S3 bucket. Other examples is what I've seen in the past, if you guys remember, where you would have the binary of WinRAR or WinZip in an archive. So as we build software, and as we distribute it around the world, and we're actually putting it at the core, we are doing this digital transformation. We should not forget about the technical debt, or the frameworks or the platforms that we are choosing, because similarly as how we laugh about the mainframe and COBOL developers, at least those works, and you don't need to upgrade Go language every year. Do you have this issue in your company where there's a Golang new version, and then you start the build process around the organization? And complexity is like an addiction. It comes slowly, forming weekly bonds that you barely feel. It's not really a bug, like what Guillaume said. It's not really a bug. It's out of scope, or it's a temporary workaround, or it's a little bit complex. But as it continues, these bonds strengthen, and ultimately you end up with systems that you cannot maintain, and that's the holy grail to rewrite all the systems. I'm very glad that actually the industry or the open source community has expanded over the past decade. So if you have leaders, I would say one of them is Netflix. And Netflix had its own problem. So Netflix is a streaming business. Yes, it used to ship DVDs by mail, but then it transformed into a streaming internet business where you can actually watch, I think it was about 4,000 devices that you can watch instantaneously your collection of videos. And I think it's really bad when something bad happens, because that's you usually enjoy sitting on a couch in your evening with your family, watching either House of Cards or some other movie which is relaxing. You try to relax after hard work working on a COBOL mainframe or Java Spring. Choose your poison. And what's interesting, Netflix was one of the first adopters of Amazon Web Services, and a good part of it is how big it became is actually the fact that AWS has a dedicated cluster just to run the bill for Netflix. Just think about it. How much data they are processing. Yes, their bandwidth is big. And I believe that Netflix on its own has a reporting system and another big team just to analyze whatever comes from that Hadoop cluster. A good part of it was they came up with this new engineering concept, which is chaos engineering. So they understood that their systems are so complex, and they wanted to create a new practice around it. So it started slowly with turning on and off VMs, halting them, changing firewalls rules, having more noisy neighbors, all sorts of disruption. And they've actually contributed this to the open source, and it's very similar to the Agile Manifesto. They created a web page because this is what you do. In order to make it like a standard, you have two choices. One, you go to ISO and you spend 5 years regarding your verbatim, or you just create a static web page with a fancy domain name. So in this case, it's principlesofchaos.org. And their definition of chaos engineering, I'll read it. It's a discipline of experimenting on a distributed system in order to build confidence in the system capability to withstand turbulent conditions in production. Well, production, okay. Some of you will shiver, like, okay, why do we do anything to our production? If not, you have the famous GIF where the DBAs are praying to keep the service up. Well, some of the outages in this region. So you have Singtel, who was fined a record $6 million for the Bukit Panjang exchange fire. You have Telstra, when it went down, you couldn't buy beer, you couldn't take Uber. You have Amazon Web Services outage when, Westpac Commonwealth Bank, which means that they are using the cloud, right? You couldn't actually access your basics, like paying your bills, paying your taxes, doing grocery shopping, and whatnot. So it's very important actually to maintain a reliable system. How can you do that? Well, one of the theories is we always do backups, right? So we do a disaster recovery, we have all these policies in terms of the changes. And the funny thing is, backups always work. It's the restores part that it's failing, and it's very difficult, especially when you haven't actually done it. So we keep all these backups for 7 years on a tape, and nobody actually tried it to restore it because it's super complex. Well, okay, so out of Netflix ecosystem, they've actually contributed the Netflix Simian Army. So the Simian Army is a set of tools for keeping your cloud operation on top of your platform. So it generates all sorts of failures. It detects abnormal conditions. It cleans up, sweeps up all sorts of anomalies. And it's a good thing that Netflix doesn't sell it as a service. So it actually a very good citizen of the open source community. First, and I think the most famous one, is the Chaos Monkey. So Chaos Monkey is active during normal work days. So that's a very it's a very big difference compared to what we currently do. We do all our changes during the weekend. It's usually outside business hours. That means that you actually, if something goes bad, you get a call between 2 a.m. and 4 a.m. with someone calling you. This is escalation manager, please join our call. And there's like 100 people there asking you to log into a system. And you're like just coming out of your bed and say, okay, give me half an hour to get the VPN token, to get all the access sorted out in order to actually get a sense of what's happening. So that's good. We can actually make sense of what's happening during our official business hours. Chaos Monkey breaks things in production. Obviously, this is on a maturity level. Please don't install Chaos Monkey and go and destroy some of your production VMs or production systems. They are doing this because the engineers are selecting a percentage of the traffic, and they are very, very similar to how we do A/B testing. Are you familiar with A/B testing? So you experiment on it, and that, by definition, because you're also it's a data-driven exercise, you're also building better software services. And last but not least is you are embracing failure. So it's like a military drill. So if you do it every Monday, then if it happens on Tuesday, you'll be okay. You actually have the scripts, and we all seen what happened with the S3 disaster. They were able to put it back up in record time. I don't think if something like that would happen in a bank or even in Singapore government, then that will be as fast. Another interesting service which I would like to mention it, because this is Security Monkey. So Security Monkey is like a monitoring agent that looks after your AWS and Google Cloud configuration, and it's able to monitor the insecure configuration. So it has like policies. You are able to configure or customize the account types, the CSPs. You can have your custom auditors. You can have custom alerts in order to sweep, and it also ensures that your SSL and DRM certificates are not expired or close to expiration. It does in a UI, but there's also a command line for it. There's also other monkeys. You have like latency monkey, which is simulating a degradation in service. It's literally injecting delays in your TCP connections. You have janitor monkey, which is searches for unused resources, or like dead zombie VMs. Conformity monkey. So this is more like detecting instances that are not following best practices. Like you have a style or a guideline, and this will inspect the EC2 instances, and it will do it in a batch manner, and it will give you an option either to shut it down or notify the owner. And Dr. Monkey performs health checks. Let me first demonstrate the Chaos Monkey. So I have an example here. I've recorded all of this. Okay. Okay, oops, had the wrong one. So this is an older demo. Now the latest ones are using Go. This is a Java demo. So it had a successful build with Gradle, which I don't need to go through it. Now I'm actually pushing this this application to a Cloud Foundry instance, which is a platform for running your applications. it takes a while, but basically it creates, after you give it the binaries, it figures out the dependencies, builds a container, and runs it inside a process. Runs a process inside a container. And it gives you a URL, which is internet accessible. So it does the routing and the network. It's able to update the routes and DNS. Okay. There's a couple of things that is happening. So in the section below, the lower down, there is a post to create a chaos. In the second section middle, there is, I'm watching for the events, what happening on the AWS infrastructure. And in the first one, I'm listing all the activities. Okay. You can see that the post was sent. You can see the event that is saying that there is a termination event, and then the instance is shutting down. So think of it like, a trigger button, please shut down my EC2 instance. And this is, you can have various configuration in terms of which instances you want to shut down, how you tag it, in terms of how you schedule it, and all of the above. Okay. But the good part is there's a quote by Ken Beck which says, it's very similar to test coverage. The fact that you have 100% test coverage, it's like reading a newspaper. You read the whole newspaper, but some articles are more important than the others. Here, I think if we're looking at the tools, we need to understand the principle behind it. Why do we do what we do? So I don't want you after this session just to go and create a Java application, point it to a REST API, and just start shutting down the instances, because what is the goal? What are we actually trying to do? What are the principles about it? Because immediately someone will take you, please create a Jira ticket to install Chaos Monkey, please shut down this, or create a report out of it. And Alex Krivitsky coined this term, which is called dejarification. And it's an interesting concept where, think of it like what we currently do. A lot of our meetings are basically where we humans meet with a tool to update the tool that will update another human. So, and those workflows are very interesting because you must change the status to reviewed, not closed. I need to change the status to closed. Or I booked a meeting room for our 2 hours Scrum. I think, ultimately, the tools are important, but the conversation and the information that is being exchanged is far more important. So, as I said, Netflix created the principles of chaos. Actually, I think all the signers or the authors were Netflix employees, which is interesting, right? So the principles of chaos, 4 of them. So you build a hypothesis around the steady state behavior, and you vary the real world events. Then you run experiments in production, and then you start automating those experiments in production. Organizations such as Amazon, Google, Microsoft, and Facebook were applying similar techniques. They never contributed it to open source. Ken Beck is very famous about his a blog about reversibility, where they were trying to tame the complexity. And complexity by inheritance, you are actually not able to define it. You can throw at it hundreds of architects, and they will come up with fancy diagrams, but ultimately, they will not be able to simplify it. So what you want in order to keep your velocity is you want to make sure that if you make a change, you're able, and if that change is horrendous, you're able to reverse that change instantly. So even if you have 1,000 breaking changes that only take 1,000 seconds, that should be fine, because your customers will not observe it because they're happening in various systems, and you're able to restart or roll it back instantly. So let's talk about the first principle. I would call it pseudo watch. So it's about building a hypothesis. So you start with what is considered a good norm of your system, and you monitor the metrics that are visible. In the principles, they say characterizations because they don't like the metrics. Metrics is just like CPU utilization. But here it's more how many requests per second, how many active sessions, how many concurrent users. So you need to capture interaction between your users and the system. And it's very interesting because utilization as a metric is virtually useless. We do have hundreds of dashboards in our operations backend where we're monitoring the CPU and memory, but we are not able to correlate. Yes, when there is a red, amber, green, when a system changes for 80%, yes, that means that will have an impact of the users, but is it really true? If our customers are calling and complaining that actually a workflow takes ages, we can see that the systems are actually all green. There's no problems in our system. So we need to track other characteristics of the systems, not just utilization. Vary events, or how I call it, pseudo halt. You can start with terminating virtual machines when you're scaling up and down. You can start injecting, to your Internet Explorer users or to your Firefox users some sort of latency. You can fail requests between services. You can fail an internal microservice like your reporting or your feedback. You can even make an entire region unavailable just to analyze what's happening with the system. So these experiments are very important because we do have environments in our IT systems that do the performance testing, that do the system integration testing, that do the security acceptance testing, that do the penetration testing. But end-to-end testing is very expensive. And it's a very slow process, and there's always a configuration drift between what we have now and what we actually what's happening in the production. And it's mainly because we're not able to replicate the whole environment that we have, down to DNS, to certificates, to key stores, or to expiration, expiration on certificates. And it's usually like a very simple use case. Like there is a paper that did a study that 92% of catastrophic events, which are not including floods, it's simple misconfiguration, which you could probably stop by just having a fail check. Like, for example, S3, the havoc that it caused, it was someone on the CLI who mixed the arguments on awk, which is a simple command. So if that sort of misconfiguration creates a havoc, you should have a checker-maker process in terms of who runs scripts and how the arguments are passed. And the other part is that your customers are not behaving like JMeter scripts, obviously. Like they don't flood the gate in 1,000 active users. They build up. Some of them have sessions of 30 seconds, some of the sessions for half an hour. They also use it on mobile, on DSL, or on fiber. So I think, being able to test it in production, you will come up with results that will not be theoretical, in our performance environment. And you need to automate all of these experiments, because if not, how are you going to observe trends? So once you start capturing these metrics and characterization, you need to see what's happening with the time. So it's no longer we're just promoting our release to production because the test or our regression test is green. We're able to observe for a week or a day that the new release is actually improving the response rate, or the peak of the users, we're able to add 10% more rather than it's worse. Because if it's worse, we can roll it back. And that's very important, because we need to look at the system as a black box and really observe the events and interactions from a user perspective. So here is, in short, like principle of chaos, build hypothesis around the steady state behavior. The way I would describe this principle as a quick read of, there's a chaos engineering white paper done in 2016, is intentionally break things, compare the measured with expected impact, and correct any problems uncovered this way. Over time, you realize that there's a common themes underlying, and you could build automation tools, you could build dashboards. It's not just simply break things. You need to understand, like, why is the reason we want to optimize, the traffic for our Chinese users or for Indonesia, in different countries. Because as we build systems, they no longer are tied to a data center or to an AWS region. They move around the geography. Yes, there's data governance issues, but ultimately it's very hard to judge about a system that is geographically distributed with various versions. So I'll give you an example. So I work for Pivotal, and this is a reference architecture for a cloud-native platform. So you have 5 domains: infrastructure, operations, deployment, runtime, data, and security. And obviously, you have these characteristics, which is a reference of what you have to have in terms of modules or components in your systems that will look after, for example, your secret management or certificate management, identity and access management, or CI orchestration, and many more. There's a white paper which is called the Upside-Down Economics of Building Your Own Platform. And the implementation of this reference is Pivotal Cloud Foundry. Now, I'll not go into the details of how and why Pivotal Cloud Foundry. You can ask at the Pivotal booth, they're experts. But as you can see from this diagram, it's a very complex system. It's powered by 26, 40 VMs across different regions. You can scale it to 100. And in production, it's actually very, very massive once you want to scale it, with when you hit a peak of adoption where you have multiple line of businesses that are adopting it. So very similar, you have what you call Chaos Lemur. So Chaos Lemur is the same as Chaos Monkey, but with the added concept of PCF, which is Pivotal Cloud Foundry. So Chaos Monkey, let me show you the demo. Okay, let me mirror my displays. It's very hard to. So Chaos Lemur is also a Java application. And what's going to happen is, because the platform itself is a set of 40 VMs, what you do is you first do a list of all the available instances on Amazon, like a dry run. So in this case, you have a MySQL instance. We've just changed the flag from dry run from false to true. So these were the selected VMs. now will actually go and kill the VMs. So you have dedicated nodes, some of them like the Diego cells. This is a component inside Pivotal Cloud Foundry, which is your container, which is running your containers. Okay, so we start seeing failures. Which is expected. And that's very interesting because Cloud Foundry has an inbuilt mechanism where there's a monitoring script or the health manager which is watching after its instances, and it's able to restart these instances automatically. So you don't need to receive a call or email to go and hit restart button. And it's able to restart them from a last good known state. And I'll just show you quickly that. So after about 5-10 minutes of the demos, you will actually have the Bosch director, which will inspect the infrastructure and will scan and fix it. And this is the AWS dashboard where you can actually see that the instances were killed and how they are restarted. A more interesting example is Locust. So Locust, as I mentioned, like a lot of the issues inherited about distributed systems, they don't showcase unless you have high traffic or you have multiple users, accessing, or there is a baseline where everything seems normal up until you actually start having, multiple geolocations, multiple line of businesses using a certain application. And usually it's very good to actually performance test. And there's two options. There's many more. You have Locust, you have Gatling. Both of them are open source. I will showcase a demo of Locust, which is sort of creating sessions for the users and then sending traffic as you would have like 1,000 concurrent users with delays in their request and different session time. So Locust will define your behavior code. So rather than like a record and play, you actually just set it up like, this is my my delay, and I would like to have a random factor between that. The wait time is 1 second to 5 seconds. So there's all this randomness that you can inject into the script, and ultimately you can have increased load over a period. So you can have scenarios that actually replicate the examples in how we use. So if you're familiar with your online banking, it's 9 a.m. to 11 that you actually go and check the page for the balances. Nobody checks the balances in the evening or midnight. So there's different patterns depending on the system that you build. So for example, Uber will have a different graphic than someone in the retail. So I'll give you an example of Locust. So you have, a simple test. Again, this is an application that is being deployed on Cloud Foundry. If you do have questions, please raise your hand and we can make it more interactive because I'm about the end of this presentation, and I would like to know if you are more interested into the practice, lessons learned, or you want to see more demos. Who wants to see more demos? Who who wants to talk about more theory and practice lesson learned? Okay, half. Okay, I'll show one more demo. So here we are ramping up the users. We create demand, and we try to simulate someone logging in and just hitting a request to let's say to an API, be it a shopping cart or see the catalog, and then logs out. So as we create the demand, there will be, it's very good if you have in your platform elasticity, because you don't want to react on this based on your dashboard. And, okay, it's 9 a.m. Let's ramp up our VMs. Oh, it's 10 a.m. Let's scale it down. Or it's 6 p.m. Let's close it down. You actually would like to automate a lot of it. And it's great because you now have tools like CloudWatch. You have all sorts of auditors and inspectors which are giving you ways for you to trigger it. In the Cloud Foundry concept, you have an autoscaler which is able to inspect the traffic, and depending on the, not just memory and CPU, we've added a couple of more features in a recent release, is based on the delay in the response to the user. So if you see a degradation in the response for the users, you can actually tell that please increase by 10% or 20% the number of instances that we have in production. And similarly, you want to do it the other way. So when you see when you see systems that are idle, you want to reduce the number of instances so that you can save on the bills. So I think all of this is very important because it's allowing you to see characteristics of the system, and more importantly, you can build these lessons learned. So you want to have a systematic approach to your chaos testing. We want to test our authentication, or we want to test our reporting engine, or we want to test our fraud detection engine. And this is very hard if you are debugging the system in the middle of the night. It's much easier and more elaborate if you are just failing like 0.01% of your traffic, and you're able to take a dump and analyze the system's characteristics, both from a user perspective and then from what's the reality in your data center. And by the way, don't wait too long to start the load testing. One important lesson is as you scale, you actually find that maybe your system diagram is not performing well. So there's a bug in your architecture, or some of the tooling that you are using is not able to scale. So you need to go back to point zero where you choose different vendor solutions, or you need to begin from scratch. So I think it's a good exercise after you finalize your MVP, and as you build your systems and you're able to make predictions about the number of users, that you actually load test the system performance. Changing the architecture, as I said, is last minute, extremely dangerous. And you need to join a community, because as much as we probably have different domains, the technology that we are building, the elastic platforms, the way we orchestrate the software-defined data center, the way we build the frameworks for our web applications and middleware are the same. So there's a lot of lessons learned that we can share with the community in terms of the protocols, in terms of the tooling, in terms of the user experience. Because there's a lot of vendor pitches where it's very simple to use, or it's easy. When they are showing you, let's say, a popping balloon exercise, it's much more harder when you have real transactions. When it's your bank account, or when you are doing foreign exchange, cross-border transactions. And more importantly, don't trust the claims that the systems make, or what's written on a wiki, or how the UML diagram, or what was the latest whiteboard, but really look at the data that you can capture from the system, what's inside, and from a user perspective. Like, how many users are we able to serve with the latest release. So for example, I'll show you a combination where you have a circuit breaker, you have Spring Cloud services, and you have what you call now chaos loris. So here, what we do is we have a circuit breaker dashboard. Circuit breaker dashboard, if you're not familiar, is very much like the surge in your house. So when there is a surge, the switch will flip, so you'll not fry your electronics. So here, when a system is failing, you do not DDoS that internal system. You basically have a fallback mechanism. So here, what we can do is, we maintain a load on the system. So we have the circuit breaker, we have the response time, and then we have the logs. So we create the application in the chaos loris, which is a tool, to creating havoc on in an organization. So you are creating here a schedule. Think of it like every 15 minutes every 15 seconds we want our system to suffer a mishap. So we create this schedule. And we basically create, so we created the application, we created the schedule. Now we bind them together. So the application targeted is being attacked by this service. Okay, so the chaos are starting to happen. And you are able to see a real system and the traffic and the load where the instances are going up and down. The services, this application is very simple. It's a microservice architecture, but there's a client and a service. So we might kill the service, we might kill the UI, and we are just want to verify in terms of what's the characteristics of our service, how many requests can it serve, under heavy load. So here you have the circuit breaker. So imagine it's something like we're doing an upgrade to a system. So we're taking like one of the data centers or one of the availability zone is down, and we want to simulate the traffic that the application is using the service, and the service is being scaled up and down, and at the same time we have events that are terminating the application, that are restarting, that are injecting failures. So for us, it's very good to understand, okay, what would be the priority one to fix? Like what kind of fallback will give us the best characteristics? So in this case, imagine we could read from a property file, we could read from a cache, we could read from a secondary database, we could read from the slave. So as we start pondering on these experiments, we're able to prioritize in terms of where should we investigate the time, where we should actually spend engineering in order to raise the availability of our service. Like, what would be the best case for the capital that we spent in order to raise the availability from 4 nines to 5 nines? Okay. That's about all. I think I have a couple of more slides. Culture beats principles, beats tools. As the old saying says, culture eats business for breakfast. As we experiment with these halt issues, or like when we're halting or terminating VM instances, we want to have a process that, okay, the incident happened. We want to see the impact of that event, And we want to create a post-mortem, which is a Kaizen principle where, we want to extract lessons learned. So yes, it was an unfortunate event. What could we do next to prevent it? Like, do we need to change the process? Do we need to look at the tooling? So in a way, you not only focus on the tools and the principles behind it, but you also want to create an organization that is a continuous learning organization. So that means, yes, today's best practices is going to be in 5 years legacy. Or now, what was the state-of-the-art architecture 5 years, 10 years ago, service-oriented architecture? Now everyone is moving away. So you want to continuously learn, and I think the post-mortems is a way for you to clean your process. And don't follow just the herd where we've been doing this just because for the past 5 years everyone was doing that. You're trying to experiment and look at the tools in your context. This is a whiteboard that I usually create where you start with an exploration phase, planning, iteration, customer approval, and you want to break your long releases into smaller releases. And in this case, I'm really talking about releasing into production, not the way we break the software release cycle. We do 2-week sprint or 3-week sprint or weekly sprint, but we still release into production every 3 months. So we want to have this feedback cycle where we go, from unit testing, which is in seconds, to pair programming in minutes, where we do our daily stand-up so we can collect the feedback from the team, where we do acceptance testing, let's say every Tuesday or every Friday, and then we will look at the results every week. So we do a planning session on Monday, and then we look at the release on Friday, or we look at the newest feature released on Friday. So there is multiple practices, and I think as you mature as an organization, you'll adopt different principles, different tools. You'll change methods, because as you scale your organization, the methods will no longer apply. Further reading, there's a great number of InfoQ articles. I do advise to see Chaos Engineering. I do advise you to see the latest video recordings by Casey Rosenthal about chaos engineering and intuition engineering, or by Josh Evans, who goes by the handle Ops Engineering, about chaos in a microservice architecture at Netflix. So he is sharing the lessons learned of what, for the past 4 years, how they changed the way they build the microservices and how the platform underneath and how their operations runbook changed. Thank you, and I'm open to any questions. Sorry that it takes too much. Raise your hand and you'll be given a microphone.
This is more technical, I guess. So you started talking about JMeter and moved to different tools. So you don't suggest JMeter, or tools doesn't matter how you use it?
So as you adopt or experiment new tooling, you need to understand why we do what we do. So for example, why do we have Jenkins pipeline that build Jenkins job? So I've seen it in the industry. We have a Jenkins job that is configured to generate other Jenkins jobs that are configuring to do build jobs. And ultimately, in all of these processes, we are inherently adding layers and wrapping in processes something that should be very simple. I, as a customer, want this feature in order to sell more products or break revenue. So I think for us, it's very much, what should you do as a priority? Should you look at the Jenkins? Should you look at Chaos Monkey? Or you should actually look at the way, the latency of the users, and then adopt something like distributed tracing, where you're able to patch together different requests across your data center and see it takes 5 seconds, it takes 1 second for our users, to use service A versus service B. So in this example, we should probably not spend that much time on backend services, but really on the front-end services, because that's where we can decrease the latency. So I think ultimately beginning with the why rather than the what and how is more important.
Okay.
So another example is like, cloud native applications. You have the 12 factor, the way you build applications in order to have a no operations platform, or the way anyone who is doing continuous integration, it's able to look at pipelines as the building block in your system, rather than configuration and jobs and triggers. So, inherently, I think as every organization is maturing, it will want to see a pipeline, from development to production, without looking at various steps that take the build, the cucumber test, or the metrics, or others. I think that is a more interesting output. Similar is the cloud adoption. I think, as Paul Moritz is saying, cloud is not about where you run your workloads. It's more about how you run it. So like elasticity is important, security, able to test new services and new geographies. It's more important than where. Thank you very much.